नहीं, ये इसका ये है। what will happen if you
Ladies and gentlemen, young innovators, mentors, educators, and distinguished guests, good evening and a very warm welcome to the award ceremony of the NASA SpaceApps Challenge 2025 hosted at Indus Altum International School, Belgavi. Today, we stand at the crossroads of innovation and imagination, where science meets dreams and ideas take flight. We, the hosts of NASA SpaceApps at Indus Altum, are elated to welcome you to the second edition of this global hackathon in Belgavi, organized in collaboration with our industry partner, Comet Care's Innovation Hub, and our educational partners, the Tamsh EdTech and Gokte Institute of Technology. Over the past few days, we have witnessed young minds ignite their curiosity, transform ideas into prototypes, and craft ingenious solutions to challenges that stretch beyond our atmosphere. As we gather to celebrate the spirit of exploration, let's remember, every spark of creativity here tonight adds to humanity's larger quest for discovery. Audience, don't you think they deserve a big round of applause? Congratulations to every participant for your passion, perseverance, and brilliance. Keep dreaming, keep building, and above all, keep reaching for the stars.
To mark the beginning. To mark the beginning of this illuminating evening, we now move to a symbolic moment of tradition, the lighting of the lamp, signifying knowledge, wisdom, and new beginnings. I request our esteemed dignitaries to please come forward and light the ceremonial lamp. Mr. Hanumant Rayappa, Founder Director, Satellite Communication Programs Office, ISRO H Headquarters, Bangalore. Mr. M.S. Patil, Principal, Gokte Institute of Technology. Ms. Chetna Sarang, CEO and co-founder, Dattamsh EdTech. Dr. Prasida Sri Kumar, Founding Principal, Indus Altum International School. Ms. Anjali Negi, Vice Principal, along with our Director of Administration, Major Mayank Johari. Mr. Sunil Ravindran, our Secondary Coordinator. Ms. Archana Kakni, our Primary and Middle School Coordinator. Ms. Gloria Bardeskar, Early Years Coordinator. And also Mr. Kaushik Yola, our Local Lead, NASA SpaceApps Belagavi. May this light dispel darkness, inspire brilliance, and guide our young innovators towards endless horizons. Introducing our chief guest, Mr. Hanumant Rayappa, a distinguished scientist and former director, Satellite Communication Programs Office, ISRO Headquarters, Bangalore. Mr. Rayappa has dedicated his life to bridging space technology with human welfare. His visionary work has transformed how India uses space for social impact, from telemedicine connecting doctors to patients in remote villages to teleeducation linking classrooms across the nation, and the Village Resource Center program empowering rural communities with knowledge and connectivity. When disaster struck in 2004, Sir was amongst the first responders rushing to the Andaman and Nicobar Island to restore satellite communication links, reconnecting hope in the midst of crisis. He also played a key role in frequency management and policy formation for the SATCOM sector, ensuring India's technological sovereignty in space communication. A recipient of multiple ISRO Team Excellence Awards and the IETERS Kanpur Gold Medal, his career embodies the ideal of science for society. We welcome you, sir. Can we have a huge round of applause for sir? To invoke the blessing of wisdom and grace, we now present an invocation dance, a performance that weaves together rhythm, devotion, and the harmony of the cosmos, a fitting tribute to this afternoon that celebrates science, art, and the human spirit. This dance symbolizes prosperity and gratitude, setting a divine tone for the day's proceedings. Please join me in welcoming our talented performers from Indus Altum International School to the stage.
Let us sit back to realize how important time and cosmos are to the inevitable human existence. Presenting Navagraha.
Yeah.
ॐ दधिशङ्खतुषाराभम् क्षीरोदार्णवसम्भवम् नमामि शशिनं सोमं शम्भोर्मुकुटभूषणम् ॐ दधिशङ्खतुषाराभम् क्षीरोदार्णवसम्भवम् नमामि शशिनं सोमं शम्भोर्मुकुटभूषणम् ॐ
A heartfelt thank you to our graceful dancers for filling this space with such serenity and joy. Innovation means finding value in ideas and transforming them into meaningful solutions. And failures are but stepping stones on the path to success. Bringing these words to life, I have the honor of inviting a true visionary, an educator who nurtures curiosity and cultivates courage. Dr. Prasida Sri Kumar, founder principal of Indus Altam International School, to deliver the welcome address.
Thank you so much to my dear students. Good morning, everyone. We are blessed to be human beings because we have been gifted with one of the most important talents of all the creatures. What is that? Why are we blessed to be human beings? We have a unique talent which no other creature has. Anyone from the crowd? What do we do differently as human beings? Yes, Zifa? You're right? Very well. Creativity and the ability to think. Creativity turns ordinary lives into extraordinary ones. Today, we are going to witness one such culmination of a creative spur that we did for the past 1 week. NASA SpaceApps Challenge, Belagavi Chapter 2, 2025. Before that, why hosting such a global event? Indus Altam International School, under the visionary leadership of Lieutenant General Arjun Ray, we believe that innovation is the spine. Going forward, with the advent of artificial intelligence, nothing is going to be the same except human creativity. Our CEO, General Ray, says, a world is being increasingly shaped by relentless technological advancement and the ever-present challenge of VUCA, volatility, uncertainty, complexity, and ambiguity. At Indus, we embrace the profound truth that education must prepare our children not just for the futures, but also for the unforeseen circumstances or the possibilities. The aim behind hosting such a global challenge here at Indus Altum International School is nothing but to embrace our vision and mission of academic excellence, human values, and fearless innovation. The aim behind the NASA SpaceApps Challenge is nothing but embracing failure, celebrating failure. It is with immense pleasure and sincere gratitude that I welcome each one of you to the great culmination of this award ceremony of NASA SpaceApps Challenge, Chapter 2, Belagavi 2025. The event has demonstrated beautiful spur of creativity and innovation invited from different parts of northern Karnataka. To our incredible participants, our dedicated partners, our esteemed judges, and the entire organizing committee, my team, Indus Altum International School, gratitude to you. We are deeply honored to have with us today our chief guest, Mr. Hanmant Rayappa, the former director, SATCOM Program Office, ISRO Headquarters, Bengaluru. Sir, your presence is a powerful inspiration and a testament to the importance of the talent gathered here. Thank you for the thought and the time, and it was a great pleasure interacting with Sir in the morning. Sir has aptly pointed out, and something that was very striking in the whole discussion we had, was he said that 98% is still not success. It is just 100%, because even that 2% failure at ISRO is considered to be a human safety hazard. So that was such a profound thought. And while we were discussing with Sir, I felt that I'm actually watching a sci-fi movie. And I told Sir that, Sir, we feel that we are watching a sci-fi movie, but for you, it is life, a reality that you have lived all these years. And the kind of humility, Sir, with which you are coming to Indus Altum, we are truly touched, and we really value your presence. We welcome you wholeheartedly on behalf of my team. We welcome you wholeheartedly to Indus Altum International School. A big round of applause to Sir. Please welcome Sir with a very small token of love for you. Thank you so much, Monica. Thank you, Sir. Thank you, Monica. This year, we all adapted brilliantly as the entire challenge was conducted virtually. Our success proves that the passion and the collaboration can even conquer distances. Conducted virtually, this challenge witnessed the enrollment of almost 403 participations, that is 85 teams from across northern Karnataka, and out of which 65 teams successfully submitted their projects. To maintain fairness and avoid any sort of conflict of interest with the regional local leads, this year's Belagavi event was limited to the participants from the northern Karnataka region. I must also take a moment to thank the backbone of the local event, our local lead, Mr. Kaushik Yola. A big round of applause to him. Thank you, Kaushik, for being the man and the strength behind bringing NASA SpaceApps Challenge to Indus Altum International School for the successful second year. Your role has been instrumental. Your motivation has been one of the inspiring forces for all our participants, I would say. And you are behind all the success stories that we have done here, or we have created here at Indus Altum through Astro. You have actually helped us touch the stars. Thank you. The success of the hackathon is a community event built on solid partnerships. First, I would like to welcome our industry partner, Comet Cares Innovation Hub, a vital part of the ERA Foundation. They were instrumental in anchoring this event in real-world application, bridging the gap between industry and academia. I think we don't have a representation of Comet Cares today, but still, the gratitude reaches distance. Next, to our educational partners, Gokte Institute of Technology. Dr. M.S. Patil is already here. Thank you so very much, sir, for gracing this occasion with your presence. And the Tamsh EdTech LLP, Ms. Chetna Sarang and her team, they are also here. Thank you, Chetna, for being an instrumental part to all our innovative projects. Your collaboration has been crucial in enriching the technical depth and fostering the next generation of engineers, scientists, and whatnot. Finally, to our distinguished judges, following the grueling 48-hour hackathon judging, the meticulous planning and enriching the technical depth of the entire participation which flew in from different parts of northern Karnataka, it wasn't an easy task, but they've done it with so much of dedication and involvement. And now, to the stars of this day, let me tell you, by choosing to participate, you have already won. So never mind who is going to be there on the stage, but with participation, you've already achieved success. Every team that utilized NASA's data to create a submission is already a winner. But yes, a selected few have created solutions that truly demand that spotlight today. Before we announce the final results, these teams have earned highly prestigious opportunity to present their projects live, a final showcase and brilliance to you. They'll be showcasing their presentations to us, and we will have that opportunity to witness that. And certain teams will also be awarded for the best use of data, best use of technology, best use of scientific knowledge, best storytelling, and the most inspiring. And of course, the climax of the evening, the overall winner, whose project demonstrated highest level of innovation and impact, earning a grand prize of rupees 25,000 and the local recognition. So these are all monetary benefits, but yes, the main spirit is in participation and the learning and the knowledge that you have gained out of this global event. So it's all, today is for you. I'm not stealing the thunder by speaking at length. Please present your work with pride, and you are actually blessed to present your work in front of our esteemed guests and learned people over here. Thank you so very much, and have a beautiful day.
Thank you, ma'am, for your inspiring words that remind us that innovation begins with imagination and grows through resilience. And now, the stage is set for brilliance in action. Our winning teams will now take us through their journeys, from the spark of an idea to the creation of impactful data-driven solutions that respond to NASA's global challenges. As you watch these presentations, innovation isn't just about technology, it's about empathy, creativity, and the courage to explore the unknown. Let's give a huge round of applause to our young innovators as they present their projects. First up, Team Spacebound. What if survival meant commanding your own destiny among the stars? Good luck.
Good morning. Good morning to one and all present here. I, Anjali Betre, and my okay. Good morning to one and all present here. I, Anjali Betre, and my friend Aoife from the team Spacebound. We are here to present our presentation to you all. The topic of our presentation is your home in space, the habitat creator. The main objective of our project is to uh, give you an overview that how a spacecraft looks like from inside, and also assures that living is also possible in space.
Good morning, all. Yeah, here, welcome to our presentation. Our presentation actually aims on how living in spaces look like. Means we are giving a 3D view to the viewers and the players. And here we are connecting astronauts and players all over the world where they can use the real-time dimensions also, as we have included it in our game. And space is no longer just a destination. It is our potential home, which is becoming like we are going in space and living there. And the next thing is our game introduction. It is an interactive game where players can play and they can understand what actually a real spacecraft looks from inside, and they can design accordingly. And we have also used spacecraft, means we have used the NASA space resources, and we have included the dimensions where players and astronauts both can use it in the same time, and astronauts can save their time to design in real time. They can use our app and they can design the interior and look what it actually looks like.
So let me explain about our game, that how does it work. So basically, the gaming starts with, we have two oxygen cylinders there. One is the minor one and one is the major one. The gamer has to fill his oxygen cylinder from the major one, and then he has to go for work in space sites and all, and he will earn point with it. And with these points, he has to invest it all in creating and furnishing the interiors of the spacecraft.
Here comes the gameplay and purpose. The gameplay is that players customize and they can earn their points based on their creativity and their efficiency, and how actually the alignment looks like. And the thing is that learning goal. And learning goal, we have said that it helps the people and the players to understand how actually astronauts live and work together in the space. And the impact, it combines fun, education, and gives the players the knowledge of the spacecraft, so that they can understand how actually engineering challenge is in real life.
Now, talking about the dimensions, as we have took the actual dimensions of the spacecraft from the NASA sites, and it will be helpful for the gamer and also for the astronauts, so that it will be helpful to understand that how the spacecraft looks from inside, because we all think that the astronauts are doing something in space stations, but here with this game we are able to understand that what does they actually do there. So here are some pictures of it. You can see it. Next slide.
And here comes the player movements. As in other games, we can move forward, backward, left, right, we can jump, run, and climb. And the main key feature is that the player has the control feel. He can feel and the environment around him, and he can enhance, it will enhance the gameplay.
So let's talk about the design of our project, which is like, first is life support system. The second one will be interior design layout, in which we have customized modular furniture, storage and workstations, optimism, layout efficiency in zero gravity environments, smart controls, resource management.
And here we conclude our presentation. Here, our presentation is mainly based on the spacecraft, how it is designed, interior designing, so that players and astronauts both can get the idea and design accordingly.
As here we have adjusted the machines and equipments to the level, as it will provide much space for work and research. Our game is helpful for those who really want to experience space life and its environment, as well as we are providing full 3D animated version of it. And that's what our topic is about. Your home is space, the habitat creator. Thank you so much for giving us this opportunity to present our project over here. Thank you so much.
Thank you so much.
Thank you, Team Spacebound, for that incredible start. Your presentation combined imagination and leadership beautifully. A true reminder that great ideas begin where curiosity meets courage. Next up, we have Team Seekers of Void. A home in space, fiction, or the next frontier.
Good morning. Good morning, honorable chief guest. Ladies and gentlemen, I am Rahul, the lead designer of the game Space on Rent.
Good morning, everyone. I'm Gautam Khatri, the lead coder of the game.
The crew member consists of Divyanshu, Dikshita, Neha, and Bhagyashri. So, we, the team, Seekers of Void, have took the challenge of space habitat. The purpose of making this game was very simple, to foster critical thinking skills amongst the players, in which they have to think logically and rationally to solve the problems in space. And also, they have to think about the resource management. That's why we also had the space logistics. Hence, they can also understand how they can build space habitats across the planets. The impact of this game is very simple. It encourages STEM learning amongst all ages, and it's also very simple. It's also accessible to everyone from who is like the age of 8 to above. Now, I'll give the lead to my friend Gautam, and he will lead you to the gameplay.
Good morning, and good morning, everyone. Let me introduce the gameplay for you. Our game is divided into 3 phases. In first phase 1 to 3, we have to construct materials, decide the shape of the habitat, and power sources for our habitat. In the key points involving in this, there are conditions given for a certain planets. For that conditions, we have to choose our shape, power, and materials. There can be many conditions, random conditions are generated for this game, and also shapes are based on budgets also. And in condition 3 and in next conditions, that is 4 to 5, we have involved space logistics. In the space logistics section, there are supplies that crew have to choose. In this, there are many supplies that crew requires for the space exploration. And the total result is based on a score system that is given in form of 3 stars. If there is 1 star, it means the base is below average base, which will be not suitable for that habitat. If there is 2 stars, it is ideal, but not very ideal for this planet. And in 3-star system, it is the most ideal station. And this was our game, judges.
So, we will see you in space because sky is not the limit. Thank you very much.
Thank you, sir.
Wonderful job, Team Seekers of Void. Your creativity and perspective on space innovation were truly impressive. You turned imagination into something both engaging and inspiring. Now entering orbit, Team GT Cube. They didn't just dream life on Mars, they built it.
Good morning, everyone. I'm Daksh from Grade 8. This is Atharva from Grade 8 and Darpan from Grade 8 and Shekraj and Ridhiman from Grade 9 and there's Pranav sitting over there. So our team is GT Cube and our challenge was the habitat layout creator where we had to create a habitat simulator or sandbox for a layman to understand.
So the issue and the reason why we created our project is that space habitats are a frontier of science. They are exceedingly complex yet exceedingly interesting. Yet any tools to create a space habitat are all extremely niche and meant for extremely knowledgeable people in the subject. Thus the layman cannot use it. So we've decided to create a simplified version of a space habitat builder where the user can essentially play around with their imagination and create a habitat, even if it isn't, let's say, scientifically the most viable.
We initially created this project in 3D software for 3D game developers called Unity Engine. Unfortunately, we faced multiple challenges in doing so with coming up with this project. What you're seeing now is is going to be the backstrip version of our project. Even though we faced this challenge, we had learned multiple things such as programming and the adding of assets and multiple areas of handling data.
So finally we came to the last tool or the final tool of ours, which gives the interface to a user which can be use their creative for their own users and change whatever they want. And it is as easy as when you click on the icons, it just take you to the workspaces. And also for a new man, as a layman, to give the information about this tool, just click on the components and it will directly go to the brief description about that, which is directly connected to the NASA data, which tells the information or the characters which a human should have for sustaining himself.
Now let's jump into the user interface. So in the user interface, we have multiple sections. So we have the moon base, the Mars colony, and the transit ship as the habitats which we are going to present. So let's take moon base for an example. We to add the modules that are essential for a habitat to exist, we go to the module library and add whichever module you would like to add. So since this dome is going to be the basis of all the other components that are required for a habitat to sustain, let's add that. So for this specific dome, we can move it along any axis the user likes. We can in fact rotate it as well to whichever angle the user would like to look at it from. So as you can see here, you can move it across any angle one wants. They can also scale it up across multiple different axes along the X, Y, and Z axis. We have other options as well, such as the Science for Nerds option, which is given by the green button over there. It gives you the mission overview on what is actually intended by us, and it gives you a model analysis based on whatever components have been added. Right now, you can see here we have only added the central dome, and it gives you a crux of what is expected out of it. The engineering part comes with respect to how one can improvise on it, how one can build it in reality, and the challenges and the challenges tab tells the possible challenges one may encounter if this specific habitat is put out there in space on another habitat, which we have chosen as the moon. There's also habitat statistics on the left-hand side over there. It gives you the mission viability on how on whether this habitat is going to sustain itself in space over there on that specific habitat.
So all the 3D models we used in this project are uploaded on Sketchfab. So anyone who wants to use these models can just access it from sketchfab.com free of cost. So this will align with NASA's vision of creating a free open sourced software for masses.
To access the project, one must click on the link that's present in the official NASA SpaceApps Challenge GT Cubed project page. Clicking on that, one must use the open a new tab extension that's present to have a completely enhanced experience of our website.
So in conclusion, we've created a simplified habitat builder so that the layman can exercise their creative juices. We plan to enhance this model in the future by increasing the scientific validity as well as adding new and more complex 3D models. Thank you.
Excellent work, Team GT Cube. The level of detail and design thinking you brought to your project reflects both intelligence and teamwork. Truly commendable. Our next mission, Team Zero Gs. When the sky turns dangerous, who's watching over Earth?
Good afternoon to everyone present here. We are Team Zero Gs. The team members are me, Skanda Dande, Pranav Burgi, and Kaustubh Desai.
Our project is Asteroid Explorers, where it's a 3D visualization tool transforming NASA's data into an interactive, engaging website. So our challenge was Meteor Madness, and we thought that NASA's data is very complex and vast. So to fix this, we bridged the gap between it by translating the numericals, by turning it into a 3D visualization tool, making it more engaging for a person to know about the asteroids. So our website is also accessible for all users. For example, the educators, scientists, researchers, you get the point. Now I would like to call Kaustubh for continuing the flow of this presentation.
Key features, exploring the trajectories. See the orbits. We can see the orbits, we can track the life path of the asteroids. Access detailed properties. Access detailed properties like magnitude, velocity, size and shape. Dynamic filtering and highlighting. So this is divided into two groups. One is safe asteroids and second one is hazardous. The asteroids which come close to the Earth are hazardous and they can harm the Earth. So safe asteroids.
The power of interactivity. This slide explains how we use interactivity to transform NASA's raw data into a meaningful experience. It shows that it emphasizes that even small asteroids can threaten and damage Earth and satellites. It introduces 3 audience benefits: students and educators, great for teaching astronomy and physics through visuals. Researchers, helps analyze orbital relationships easily. Public, raises awareness about asteroid hazards and similar dangers. Impact, accessibility and awareness. This slide highlights project's real-life capabilities. Enhanced STEM education, makes learning space science more engaging for students. Improved digital literacy, converts NASA's complex data into easy-to-comprehend visuals.
Looking forward, what is coming up next? So we have other features like instant meeting collabs, and the PPT is very simple for the students to understand. Launch Asteroid Explorer.
So this is our project, Asteroid Explorer. The green and red dots you see here are asteroids. Now, by simply clicking on an asteroid, we get to know about all of its basic information, like its name, estimated diameter, closest approach, velocity, and missed distance from Earth. Now, by searching up the name in the search bar, we can see the asteroid isolated along with the Sun and other planets. We also have a filter option where we can see all the hazardous asteroids along with all the safe asteroids. Now let's head over to the overview tab where we can see the total number of asteroids, the hazardous asteroid, and the safe asteroids, along with other statistics like average diameter, closest approach, and velocity statistics. Thank you for joining us. We hope you enjoyed our presentation.
Well done, Team Zero Gs. You transformed complex data into something accessible and impactful, reminding us how technology can protect and empower humanity at once. Now next, we have Back to Earth, Team Nova Corps. What if the weather could finally keep its promises?
Good afternoon, everyone. We are the team Nova Corps, and this is my team. I am Taki Altaf, she is Askia, and she is Arsin. Our challenge was, will it rain on my paradise? So the paradise means the earth. Will it rain on earth? So we have to calculate the odds of the weather happening on the particular location or the location which we want. So as you can see, we can input in our website the location of the place. So like today's we are nearest to Kakti, we will choose Kakti or Belgavi. As you can have chosen the location Kakti, Arsin will continue.
As he explained, I would now like to continue with the next part, which is about the date. We need to select a specific date, like today's date. Alternative, we can also select a date range. For example, from 1st September to 31st October, the selection can be based on the requirement of the analysis. Now, Askia will continue.
As she mentioned, the weather's odds can provide the weather's probability. Weather's odds can also provide the specific condition. The user can select the 6 specific condition. So the first condition is very hot and second is very cold, which is below 32 degree Fahrenheit. And third condition is very wet and fourth condition is very windy. And fifth condition is very uncomfortable, which means very extreme. And sixth condition is very comfortable, which is 65 to 78 degree Fahrenheit.
So for today, we will, for example, we will select the very hot as the weather conditions, and we click on the analyze data. Single click. As you can see, after the input of all these location and date and the weather conditions, it will calculate the probabilities of the weather happening. So how it will be calculating? So we have used the API of NASA data, which stores all the information of the weathers of a certain locations of longitude or latitude, and it will analyze the whole data from the year 1948. So we are requesting the API. It's not working because the API has rejected our key. NASA has provided us API for the 2 days as the challenge was for 48 hours, and it's not working right now. I would have shown you, so it's not working right now. the data which we have to download it. So the data of the precipitation or the humidity which we want to showcase in our website contains 100 GB, and we cannot upload that much of large data on a cloud without any funding and all. So we have requested the NASA to give us the API which we can request the data from and analyze the data and showcase in our website. So if it would be working, it would be have shown you the probabilities of that weather happening on that day in a scale of 50 out of 50. What is the probability of that weather happening at that day and at that location? So for very hot, it would have shown you that the probability of Kakti today, it would be like it's hot. If it would be hot now, right now, it would be shown you approx 40 or 30%. And it would also show you the confidence level of the website, how much it is confident to showcase the data. As we also use the Open Meteor data, Open Meteor data is also associated with NASA data. It analyzes the weathers, approximately the weathers of the locations which we input, and it provides the humidity and temperature from the year 2020 to 2025. And in a historical table trends, we have also included the map here to showcase which the location was pinpointed like accurate. It would also be shown longitude and latitude, and also we can export the data in CSV form or in JSON form. So the basic need to make this app was to check the conditions and the weather conditions of certain locations. Like if you are planning on a trip in a post period, like we are planning to attend a trip in upcoming days. So we can know the probability of the weather, which is good, which is very comfortable or very hot. Example, I am going on a beach for holidays, so I can check it is hot or it will be raining in Goa. Example like that. So this app can be used to plan other events also. Today, like we have planned NASA's award ceremony, we can also, in the upcoming days, we can use this app and to check at that day which we are trying to keep the event, will be the weather good or the dignitaries which are coming will be face some issues or not. So this website will be helpful in future if NASA provides us the API keys and everything. Thank you so much. This is Team NOAA, and special thanks to all of you to providing us the stage here to showcase our presentations. Thank you.
Thank you so much.
Thank you, Team Nova Corps, for a presentation that was both practical and creative. You proved that innovation isn't always out of reach. Sometimes it starts right here on Earth. Now, we have Team Periapsis. When the sun speaks, how do we listen?
And our fellow participants, my name is Zafar.
And I'm Arya.
And our third teammate Yash is not here today. We are Team Periapsis, and the challenge that we've chosen is Tell Our Stories. In this challenge, basically, we had to create a story where we're showcasing what space weather is, we're defining it for the normal person, and we're also showing it through the eyes of someone who's experiencing the space weather event. Now, for the normal person, usually, when we're watching a scientific video or anything, it gets boring after a while. And that is the problem that our team is tackling. Now, instead of just making a normal video, an educational video, we decided to make a user-friendly theater experience which most people are going to find fun. And this is for the normal person so that they find it interesting, they find their interest in space. Our virtual theater provides that platform. And to make it more impactful, instead of just making up a story about a space event, we decided to choose something from history. The Quebec blackout, when a region in Canada experienced a blackout in the entire city due to a space weather event. Now, not many of us know about this now, do we? And that is exactly why this is so impactful.
So I'll be guiding you through the whole cinematic experience. As soon as you enter into the site, you're greeted with a beautiful boot animation straight from 1989. Shortly after, a small intro about space weather is played. Talking about our first feature, which is the blackout map. It's a key set of areas of interest which are affected by the blackout, and statistics pulled from countless research papers and verified put into each point of interest, as you can see here. So moving forward, our second feature, which is the AI historian. It's basically like having an expert at your fingertips. Let's say a user has a doubt in whatever chapter they watched or video they watched. They can easily get it explained through the AI historian. So you can see it in action here. The AI is connected to our own custom database filled with research papers about the Quebec blackout and also linked with other backends such as Suprabase. So as you can see in action. And finally, our most important feature, which is watch chapters. Currently, we have 3 chapters ready. Introduction, which is the teaser of the blackout. Utility workers who have been plunged straight into the middle of the crisis, trying to restore electricity frantically. And also the general public, who have been plunged into darkness, waiting for help in order to be restored. So this project has used over 1,240 lines of code, carefully optimized and robust. We've used tools such as Unity, Blender, Vite, HTML, TypeScript, Premiere Pro, After Effects, Vercel, and CSS. Just digging deeper into it, Unity and Blender is used for scene setting and 3D animations, while Vite, HTML, TypeScript, and Vercel is used for robust stability, scalability, and also modern optimization. And Premiere Pro and After Effects were used for a cinematic experience. So this project isn't just about the Quebec blackout. It's to prove that technology, when bundled with creativity, we can look at history in ways we've never seen before. Thank you.
Thank you.
Beautifully done, Team Periapsis. Your project brought together science, storytelling, and an emotion, showing us how data can speak to both the mind and the heart. And finally, we have Team Terratoons. They turned Earth's data into a story, one we can't afford to forget.
Hello, hello. Hello. A very good afternoon to our respected judges, mentors, and everyone present here. I am Mubin Jamada, the team leader of Terratoons, and our project is called TerraTales, a storytelling-based web platform that visually narrates how our planet Earth has changed over all these past 25 years, which is seen through the eyes of NASA's Terra satellite. Here are our team members: Mr. Yusuf Sayyed, Mr. Laik Sheikh Surab, and Ms. Nitishri Bani. Yusuf is helping me with the slides and the presentation. The other two are present in the audience. So, what exactly is TerraTales? As we know that, Terra has been observing the Earth since the year 1999, observing major parts of our planet such as land, oceans, and atmosphere, capturing detailed records from melting sea ice to atmospheric composition and to global croplands. But here's the challenge. Though NASA provides open access to all the satellites, scientific, and incredible data, it often seems to be scattered and spread across multiple platforms. And with TerraTales, we wanted to change that. With TerraTales, we bridged that gap. We saw an opportunity to connect public, the local people, everyone in general, the general audience. Because for a general audience, it might be complex to go around different platforms and search to find, connect, and even understand the data and what is exactly happened and what is exactly happening through the years. And there we saw the opportunity. With TerraTales, we bridge that gap and bring together the 25 years journey of a planet Earth into one single platform, TerraTales. So, from students to policymakers, from researchers to educators, TerraTales is for everyone. So, instead of showing just isolated visuals, we curated, filtered, and arranged the 25 years journey of our planet Earth into one single platform, a continuous timeline So we decided that we have to make something very practical that is easy to understand and which is based in a form of storytelling. So it is very quick and simple for the audience to understand. Now, as I told you, that Terra Tales not only focuses on creativity, but also how the audience can get in touch with the planet Earth and exactly what is happening in it. So I would now request one of our technical member, Mr. Yusuf Syed, to kindly come up on the stage and explain the tech behind Terra Tales.
Hello everyone, good afternoon. I am Mohammad Yusuf Syed and I am the technical member of our team. And in our technical team, we have used specific languages to build our website, such as hypertext markup language for the structure and cascading style sheets to make it attractive, and also JavaScript to make it interactive and functionality. On the other hand, we have used Flask as backend, which is a Python framework, and we have used it, which made our website look more attractive to users and made our website very responsive and engaging. That's it, thank you.
Thank you, Yusuf. So as I said, Terra Tales is a platform that is simplified, visualized, and is told as a story. So let me continue with a demo of our website. Thank you for having the patience. Okay, so here we have Terra Tales. This is how our website looks like. On the home page, you can find multiple topics that you may want to explore. So for example, if the user wants to know about global croplands, when you click on this topic, a page appears with an animated video that comes along with a video. So we have scripted our own voiceovers using AI tools like 11 Labs. So this video contains audio along with it that narrates in a simple manner and an engaging manner and tells you what all exactly has happened and how our planet Earth has changed with respect to that particular topic. So let me give you a glimpse of that video.
From 2000 to 2020, NASA's Terra satellite has tracked the remarkable journey of global croplands, measuring growth, stress, and transformation from space. At the start of the 2000s, croplands covered close to...
Okay, so moving forward, on the same page, you will find a 25-year journey summary relative to that particular topic which you wanted to explore in a simple, engaging manner. And it is very quick to read out, won't take much of your time. You can connect with science and what's exactly happening with the planet in just very quick amount of time. So you can read out the summary, and that tells you the unique events, the data, and what all has happened. Then next, for each of the topic, we have a conclusion page. When you click on the conclusion page, for every topic, you have a comparison for the Earth in the year 2000 versus in the year 2025. And below that, we wanted to provide something that could click and connect with the user and to make him understand that he has a role to play in the preservation, in the conservation of our planet. Then we thought to provide a clear what you can do action plan for the user that can connect the users with our Terra Tales. So here we have a clear what you can do action plan for every particular topic, and that is because every story should inspire action and every change starts with awareness. And then I would like to introduce with one more tab that our team had put very much focus on and brainstormed, that how could we make that wow factor and how can we even more engage the audience with Terra Tales. So here we have why us tab. So as to why Terra Tales and how is it different, why you have to choose Terra Tales. Here when the user clicks on the why us tab, in a very quick short way, he can just read out as to why Terra Tales. And that is because we provide visuals, audios, text, images, everything at one single platform. You need not go on several websites and get confused. You have everything here with Terra Tales. This is because in a world overflowing with data, we focused to bring clarity, to bring curiosity, and to bring connection. Because we wanted to turn science into a story that anyone and everyone can feel and understand. Terra Tales is not just a website, it's a visual story of how our planet Earth has evolved over all these past 25 years. Because understanding our planet's story is the first step towards protecting it. That's all from my side. Thank you so much.
What a powerful way to close. Thank you, Team TerraToons, for turning Earth's story into something deeply human. A gentle reminder of our shared responsibility to protect it. What a journey! From designing homes in space to defending Earth below, these teams have reminded us that future doesn't arrive, it's built. Built by minds that question, hearts that care, and spirits that dare. So one last time, let's give a thunderous round of applause to these incredible innovators.
And now, the most anticipated moment of the evening, the prize distribution ceremony. Before we announce the winners, we'd like to extend a heartfelt gratitude to our respected jury panel. Ms. Rekha Gurwagol, Ms. Ritika Talekoti, Mr. Shashwat Sikharwar, Mr. Kiran Etaigi, Dr. Manjula R., Dr. Mayur Jatarkar, Ms. Girija Shetty, Mr. Kaval Arora, Ms. Girija Shetty, Mr. Amey Kadle, Mr. Vinay Shetty, Ms. Vidhi Sharma, Mr. Anup Bettegiri, Dr. Shikha Tuteja, Mr. Abhijit Bhatkal, and Mr. Balemurthy Bhaskaran. Your mentorship and insight has been the guiding light for our participants through all these challenges. Now, may I request our chief guest, Dr. Hanumant Rayappa, along with Dr. M.S. Patil, Ms. Chetna Sarang, and Dr. Prasida Srikumar to kindly present the awards. Before we begin, we would like to invite a team that has been nominated as the Global Problem Solver for Global Judging. Please welcome Team TerraToons with a loud cheer. Each winning team will receive a cash prize of 5,000 rupees in the following categories. Ladies and gentlemen, first up, the best use of scientific knowledge goes to Team 0Gs. For their grounded imagination in science, turning theory into tangible reality, let's welcome them with a loud cheer. Next up, the best use of data. We warmly welcome Team Nova Corps, who showcase that numbers don't just tell stories, they reveal truths that shape our world and beyond. Let's give them a huge round of applause, please. Next up, for the best use of technology, we welcome Team GT Cube. They didn't just use technology, they commanded it solve challenges worthy of NASA itself. Up next, we invite Team Seekers of Void for the most inspirational project. They've lifted spirits, sparked hope, and reminded us why we explored in the first place. Now, finally, for the best storytelling, we warmly invite Team Periapsis, for whose innovation is nothing without the story they make people believe in. And now, the single best project will be named the overall winner of the Belagavi Challenge, earning a grand prize of 25,000 rupees. This award goes to the team with the most innovative, impactful, and well-executed solution. And that team is Team Spacebound. Can we have a huge round of applause, please? C. Clarke once beautifully said, "The only way to discover the limit of the possible is to venture a little way past them into the impossible."
To honor those who have made this journey possible, I would like to request our local lead, Mr. Kaushik Yola, to kindly felicitate our chief guest, collaborators, and partners who have helped bring this event to life. We would now like to invite our esteemed chief guest, Mr. Hanumant Rayappa, to kindly come on the stage to receive a token of our heartfelt gratitude for gracing this occasion with his presence and inspiring us with his remarkable contributions to science and innovation.
Good afternoon. Good afternoon to everyone. So, respected dignitaries on the dais, Dr. M.S. Patil, Principal, GIT, Dr. Prasida Shri Kumar, Principal, Indus Alum International School, Ms. Anjali Negi, Vice Principal, Indus Alum International School, Ms. Chetan Sarang, Co-founder, Datansh EdTech, and Mr. Kaushik Yola, and dear students, I'm really overwhelmed with the program and the participation of students and the kind of interest all of you shown in this challenge, NASA SpaceApps Challenge 2025, picking up the different challenges, accessing the data, and coming out with some innovative ideas to present it, how it can be used for the Earth applications as well as making space homes or inhabitations in the space and on the moon. It's very impressive. And first of all, as far as the school is concerned, I went around in the campus, and such a serene atmosphere here, surrounded by lush green environment and away from all the urban disturbances. An ideal location and ideal environment for acquiring the knowledge, getting the education. So I must thank the visionaries, the management, the administrations of the school for providing such a wonderful facility and atmosphere for imparting the education. And also I noticed that not only providing the education based on the curriculum, that too an international curriculum, also providing focus on overall development and overall personality development of the student at the young age. And the most and quite impressive thing is having a telescope here within the campus, so that kindling the inquisitiveness amongst the students to look at the space and universe and try to understand that. Space, the outer space, has been a thing of amusement and excitement, a thing of mystery. Whatever knowledge known to mankind about the universe and about the people is just a smallest of the percentage what is available, what is still yet to be discovered, yet to be invented. It is still lot to be learn about the universe, lot to learn about even Earth as well. Since 1957, looking at the space was through various observations, observatories, collecting the data, making research on the data, observed data, and coming out with some innovations, coming out with new discoveries about the galaxies, about the planets, about the stars, about the black holes, about the twin stars, even about the birth of the universe itself, whether it is a big bang or whether it's a big boom. But from 1957 onwards, thanks to the physical laws of Isaac Newton and Kepler, about understanding about the forces behind the orbits and how an artificial satellite can be placed in the Earth's orbit. Those are the first stepping stones in getting into the space. From 1957, with the start of Sputnik satellite from Russia, so human efforts to go to the space and look towards the universe and look towards Earth started. From 1957 to now, 43 plus 25, in about 60, 62 years, the progress made is tremendous, unimaginable. Today, the space has become a part and parcel of everyday's life. For example, some of you presented about knowing the weather. So like today, the technology enables us to forecast the weather precisely to the level of in a city or in a locality, what is going to be this afternoon, this evening, or next month and over a period of time, to decide whether to conduct an event indoor or outdoor, or to have a cricket match or not, or to go for an expedition or not. So such a level, that is one example, applying space observations for weather forecasting. Similarly, space data is giving a lot of inputs even to monitor the climate changes, space environments. There are so many things which is from the scientific aspects. Coming to day-to-day life, which impacts the day-to-day life and human activities. Again, the Earth observation or the remote sensing has a very, very, very important tool in day-to-day life. For example, to estimate what is going to be the food production this year, the satellites give very important data based on the sowing activity. If you know how many hectares of land is sown by different crops, it is possible to see from the satellite what is the acreage a particular crop is sown across the country. So today in India, we have the capability to monitor from space for about 25 crops: wheat, rice, sugarcane, etc. So based on the rain patterns, the sowing patterns, so based on the satellite data, we are able to forecast what is going to be the food production of different crops. So it's an advanced information for the policymakers and government, how to store the produced food, how it is going to impact the food requirements, whether it's going to be surplus or scarcity. If it is surplus, plan for an export. If it is scarcity, plan to preserve it and have a plan to import it from a source elsewhere. So this is how it is going to help to manage the food for the country. This is one example. Again, coming to planning the disaster management and support. Cyclones. Today, India is much advanced in forecasting the cyclones. From the last 10 years, the the casualties in terms of due to cyclones is very, very minimal. So today they are able to give well in advance, 2 days or 24 hours in advance, saying that what is going to be the intensity of the cyclone, where it is taken formed, what is going to be the intensity of rain, and what is going, and the entire Indian, the surface is mapped in terms of 3D elevations. So you are able to have a mathematical models to say that if it is going to be this many centimeters of rain, a priori you will be able to forecast this is going to be the inundation area. This is the overflow of the rivers. This much beyond the river, 1 kilometer, 2 kilometers is going to get affected. The crops get affected. The houses get affected. So there can be an advanced plan to relocate the people to habitation centers, take them to a safe place, manage them, so avoid the impact of the cyclone effect. These are quite few examples. Similarly, to plan an urban planning. So using the satellite data, you can effectively plan what was the Bangalore or Mumbai or even Belgaum 20 years back, 30 years back, 10 years back. The urban sprawling, the way it is going to happen, how the urbanization is happening. So you'll be able to predict what is the resource requirement for the next 10 years, 15 years, how the urban planning has to happen, where the ring road has to come, where the wastewaters has to be managed. These are all the inputs which is coming from this space data to follow. I'm just quoting few examples. If you go by that, nearly 300 plus such applications are used in day-to-day life using the remote sensing satellites. That is the capability of the space. Of course, India is one of the top 6 spacefaring countries, particularly in terms of applying the space data for human life and day-to-day life. India stands among the 1 or 2. So there is a tremendous significant made in the space program. That's why Indian space program is hailed as a application-based program. Initially, we started not to go to moon and not to go to Mars, to address the needs of the people, to support the national development, to address the basic issues which we are facing on day-to-day basis. That's how we took off. We have achieved much significant capability, not only in building rockets, not only in building satellites, also in developing sensors, detectors to look at the space, look at the Earth, look at sun, look at different planets, and gather that data and apply it for on day-to-day basis for the economic, for the development, and also to advance the science and exploration. Similarly, one such example is navigation systems. In India, we have a domestic, a sovereign navigation system called NAVIC. NAVIC provides similar to GPS information, but NAVIC is our own Indian own system. It provides two kind of inputs and two kind of applications. One is for the civilian use, like whatever we receive the navigation signals on the mobiles. Today, navigation has become so part and parcel of life. If I want to come to this place, I don't have to ask anywhere on the en route. Just go to the Google map and see that it takes us there. So there are similar lot of things, even all app-based service delivery applications today, be it Zomato or be it Swiggy or be it Porter, whatever it is, even Ola or Uber, they are heavily dependent on the digital maps, which needs position as an important input. The position information comes from the satellites, navigation satellites. So India has built, we have built our own system, navigation system called NAVIC. So it supports for civilian applications and also inputs for the defense services, called what is called restricted services. The restricted services are more reliable, more accurate. It is used only for the defense applications. So apart from that, we also have in the navigation domain what is known as the SBAS systems, space-based augmentation system, which we call it as GAGAN for India, that is Geo Augmented GPS-enabled navigation. What it does is, with a wide range of ground stations, about 15 to 20 ground stations installed at various parts of the country, it continuously collects the navigation signals from the civilian domain. It estimates the errors, and there are errors comes from 2-3 parameters. One is navigation system need a very accurate clocks on the satellites. So navigation satellites carry atomic clocks on the satellites. All that atomic clocks on the satellites are synchronized to a very accurate time system on the ground. So it's a continuous process. So 1 nanosecond of time error in the satellites, nano, you know that, 10 to the power of minus 12. So 12 zeros after 1. So 1 nanosecond, 1 in 10 to the power of 12 error in time can lead to 1 feet difference in the position. You assume that all satellites will have some 10, 20 nanosecond, not milliseconds, microseconds. It is a nanoseconds. Then the error will be in terms of several meters. Instead of showing road here, map will show road somewhere else, which is actually not a road. And if you want to reach precisely, there are so many precision applications. For example, aircraft landing. If it is, the position error is there, instead of landing on the runway, there is a risk that it lands on the sideways. So in order to do that, the augmented system helps to improve these errors. And with that space-based augmentation systems, the aviation sector has adopted automatic takeoff and automatic landing. So, and en route pilots, the aircraft cruisings are 100% today, they are all autopiloted. It is a computer which takes the aircraft. Pilot acts as just an operator and sit and watching. If there are no errors, aircraft flies on its own. That is an easier thing. The complicated things are taking off and landing. Landing is the most complicated operations in the aviation. So with these augmented systems, even the landing and takeoff can be automated. At the major aircrafts where they adopt these space-based augmented systems, the aircrafts can get the capability to land automatically. So that is the advantage of the technology. The similar thing is also used for, that is the civilian application. In the other application, there can be unmanned aerial vehicles, which can be used for surveying, which can be used for surveillance, which can be even used for defense activities. So this kind of accurate data is very, very important, crucial to reach the accurate paths, accurate trajectories, and accurate destinations. Even in the civilian applications, agriculture, the future agriculture is going to be, is envisioned as everything is mission dependent. Human will become only observing and monitoring and operating. Actual work will be done using the machines. In order to do that, the communication and the navigation are going to be important inputs, and which comes from the satellites. Similarly, on the other side is the communication. Today, communication, we are going to a future democracies, our future lifestyle, our future economies. Everything is digital. Even if you switch off power for 1 hour and you are in a dark, the kind of anxiety, the kind of thing you get. Similarly, you keep the lights on, but you switch off the data or digital connectivity, we feel, because many things cannot happen. If it switch off for, say, half a day, banks cannot function, metros cannot function, aviations will not function. So you need, and maritimes, you go deep into the sea, you will not know where you are, and if you want to connect to that. So this is the important requirement, communication requirement. Every part of the globe is an essential requirement today, and that is achieved using, in the urban places, the continuous, reliable communication achieved using the terrestrial means, OFC connectivity, microwave towers, cellular networks, etc. On the remote places, on the mountains, on the islands, on the oceans, in the air, the communication is achieved through the satellite. So the communication satellites operate from the geostationary satellites, which are at the altitude of 36,000 kilometers, and some of the satellites today are at the LEO. They are at the altitude of 400, 500, 600, 700, and 1,200 kilometer altitudes. So at geostationary, one satellite is sufficient to cover a wide region, whereas in LEO, low Earth orbit, the satellites move very fast. From a given location, the visibility to a LEO satellite will be about 6 minutes. So if you are a user terminal, the satellite rises here, comes like this and goes and sets down in 6 minutes. The user terminal should have the capability to continuously receive from. So one satellite is not sufficient to provide a continuous communication from the LEO, so you need multiple satellites. So the LEO constellations typically have 600, 1,200, 3,000, and today LinkStar, which is given by SpaceX, Elon Musk, has 8,500 working satellite in the 3 different orbit shells of 530, 560, and 580 kilometers altitudes. So that's where they'll be able to ensure global connectivity using that. Of course, there are challenges. One is the technological aspects. You have to keep flying the satellites to ensure that all satellites are available. If there is a failure of satellite, another redundant satellite has to come and take over. That is the design aspects. And you have to keep launching. Then you have to keep your launch vehicles produced. And today, SpaceX has the capability to launch every alternative day. About 220, 250 launches in a year. If you take it there, every 1.5 days, one launch happens. And today, every 6 hours apart, they launch. In a day, 6 hours apart, they launch 2 launches. So this is the kind of thing, manufacturing satellites, manufacturing rockets. The philosophy itself has changed from a highly technological thing to a production-oriented process. The technology comes while designing and realizing and testing the system. Once it is established that, yes, it works, then it goes in a production mechanism. Continuously, it keeps produced and launched. So this is the technological utilization and application aspects. But when it comes to, again, I wanted to just touch upon, because you are the future people, you are thinking about the future. The overcrowding of LEO systems, low Earth orbit, creates a lot of problems. One is the space spectrum is a limited spectrum. Electromagnetic spectrum, you know that for space-based communication, you can use a C band, you can use a KU band, you can use KA band. Each of the spectrum bands provides about some 1 gigahertz, 3 gigahertz, and 10 gigahertz of spectrum available. If you translate into your data requirement, if it is dedicatedly given to you, it is just enough to support some 25 students, not 8 billion people. So you have to have a plan to use on a shared basis. So that is the thing, and shared basis by a single operator. And if there are multiple operators, because this is natural resources, the international regulation says that space spectrum and orbits and outer space belongs to humanity, and it should be effectively used, and it should be optimally used, and it should be accessible to every individual country and every individual citizen or person. So that is the global regulation. So in that, there are a lot of regulations to divide the orbit spectrums, orbital heights, and given a spectrum, you have to have a plan to reuse, and you have to avoid interference to that. These are all the different technological challenges in realizing these systems and providing the applications. Of course, in India, today we don't have communication systems from the low Earth orbit. We have all the communication satellites, more than 18 satellites from the geostationary orbits. But LEO also is an important thing. We are working on that. But currently there are global players like SpaceX, OneWeb, and Telesat from Canada, and China, and India is also getting into this very shortly. And the last one is the taking human to the space. Space exploration. Space exploration is an important thing where is important. One is the scientific aspects, other one is our own capability to go to space and take the human species to the into the outer space, have life in other planet elsewhere other than Earth, so that you can have the continuity of this human space. That is the thinking. Suppose if something happens to Earth, if there is a major disaster which reduces the human species significantly, so you can have an alternative planet, an alternative celestial body to continue your living there. That is a very ambitious and future. That is protecting humanity. And second one is commercial aspects. You may find new elements there which can be used for the energy resources here. You may find something new which is not available on the Earth and its atmosphere that can be useful for the commercial activities. You can bring some new material to make chips, some new material to make batteries, some new material to make new medicine. So these are all the economic possibilities where now people are focusing. And going to space and undertaking these kind of missions has become accessible now compared to 10 years back. Launching 1 kg of any object carrying 1 kg into space was costing about $20,000. Today, launching 1 kg of substance to space costs about $5,000. Of course, now there are too many players, multiple players. They are optimizing space vehicles, customizing space vehicles. They are inventing new propulsions. So that may even bring down the access to space and the cost to access, so that there will be multiple options, multiple choices, you can quickly go and come. Going beyond Moon and Mars, the systems there work with the solar energy. Solar energy is the source of electricity. Suppose if you go deeper inside, beyond Saturn or beyond, you are going to Uranus or Neptune or beyond even solar system, there you may not get the enough sunlight to provide the required electricity to the spacecrafts. So you need to have the capability, nuclear capability to generate electricity and go. So these are all the new challenges. And taking humans to space, again, there are three. One can be a space tourism. Take the citizens, any civilians. They need not be cosmonauts or astronauts. They need not train aggressive thing, because it's just a 3 minutes, 4 minutes. Overall space tour will be about half an hour. You go there up to the 100 kilometer, feel the zero gravity, have a look at the universe, have a look at down to the Earth and come back. That is one kind of activity that is being done by many commercial players. It has become a tourist. You just pay the money and go get a ticket and go and come. Then second one is getting into the orbit. There you cannot go for hours, you have to go for days. You have to be there for 1 day, 2 days, 3 days, because the entire mission profile takes that much of time. Then there are a lot of challenges comes into picture. Then you have to have a human support system, life support system, environment control system. There you have to have the physiology of the Earth. You have to have the providing oxygen, enough pressure, managing human waste, monitoring human health. There are so many challenges. Suppose if something happens, you have to have a mechanism to escape from that and come safely to the ground. Now imagine you go to the moons and Mars. It becomes a going 1 week, coming 1 week, staying there for 1 week. It becomes a month program. Then the technologies become more complex. To give you one example, I take from Chandrayaan 2. Chandrayaan 2 had 3 different modules. One is orbiter. When we launch, all the 3 go as an integrated system: an orbiter, a lander called Vikram, and a rover called Pragyan. So all the 3 are integrated into one single system and launched into the space. When it goes to the moon's orbit at the altitude of about 100 or 200 kilometers, the orbiter remains there. The lander and the rover as a single integrated craft, it has to be disband and it has to come and land on the surface of the moon. We go up to the altitude of 2.7 kilometer. Then only 2 seconds is left, it has to come down and soft land on the moon, but it did not happen. From 2.7 kilometer, it crash landed, it crashed. So once it crashed, no data, nothing, and afterwards you have to only monitor from the orbits and see that. If you get the data and analyze that, it is understood that, and before going to that, one more point I have to do that, all these missions to moon or missions to Mars are autonomous missions. The spacecraft itself has to make its own judgment, its own decisions. It is not that you send a command, the command goes there and some activity happens and then only it responds. No, it's not a responsive thing, it's all autonomy. It has to take the inputs, it has to have its own sensors, its own actuators, it has to act to the environment and it has to execute and land them. It is an autonomous system. So if you see that up to 2.7 kilometer, everything has worked fine. But so it crash landed. Then the ISRO analyzed the data nearly for about 1 year, everything. Prior to that, everything was done based on the simulations, based on the knowledge available to that date. But this data gave a crucial information that the area in which we have to scan to identify where we have to land, we were planning 1 kilometer by 500 meters, looking at the capability of the sensor. So in this Chandrayaan-3, it was decided we have to enhance the area to 2.5 kilometer. And the legs of the Vikram, it was felt that it has to be strengthened. In Chandrayaan-3, it was strengthened. So all other logics, all other algorithms validated once again, everything was fine. So Chandrayaan-3 became success with kind of thing. You all know that 23rd of August 2023 is the day Chandrayaan-3 landed on the moon surface, and we are celebrating that as the National Space Day. Again, as part of the National Space Day, as part of ISRO also, we are taking a lot of activities to enthuse students and acquire knowledge about the space and space-based systems. So with these kind of things, there is a lot to do that. Now, in the future, if you look that in ISRO, we are focusing on undertaking Chandrayaan-4 program, where we focus to bring the sample from the moon and analyze. And Chandrayaan-5, again to have a much bigger rover, much bigger lander, so that you can make more discoveries on the surface, more research on the surface about the composition of the surface, the material, and the gravitations, etc. There are so many things. And also we are planning one more mission to Mars, one more mission to Venus, Shukrayaan, and also to have India's own space station called Bharati Antarik Station, and also to have an Indian citizen landing on the moon by 2040. These are the ambitious things which are giving a lot of opportunity for the industry, students, academia to contribute. ISRO alone cannot do. ISRO is mainly, we are focusing on the design, the science, physics part of it. When it comes to technology, realizing systems, simulations, software, operations, ground infrastructure, everything we are depending on academia for the inputs, industry to deliver the products. This is how entire thing is structured. I think in next 15 years is going to be a golden year in the space era of Indian space era. I think with this, for the students, I am really impressed that the way you have looked at the data from the NASA website and apps from them and try to bring out something meaningful in that. I think this is the just beginning. If you continue to do that, you will try to understand how the whole thing is done. You will understand what's all done to create this kind of data. Second one, how the data is going to be utilized for the applications which you have just attempted. You can also think the new possibilities, how it can be taken forward. What are the shortcomings there? What is the data gaps there? Suppose if the data were to be available, I could have further fine-tuned or enhanced my application or my game to perform better, to give more data. That is the kind of inquisitiveness we have to have. In space, as I was talking to Madam, Success is 100%, even 99%, 98%, and 2% failure can lead to a catastrophe, a total failure of the mission. So it has to be, in space, it is not the systems and component cost too much. It is the testing facilities, it is the simulation facilities which cost more. It takes more time. So taking from that, acquiring new knowledge is a continuous effort. It just doesn't come just like that. So success is based on the perseverance. And failures are the stepping stones to take it forward. Failures give valuable insights and valuable inputs to correct the system, to understand the problem and make the system perfect and make the mission success. As far as competition is concerned, as far as competition, it's like a running 100 meters. The person who clears, in example, say 12 seconds, 100-meter distance, becomes the winner. And the person who finishes in 12 seconds, 0.2, is not a winner. That is the game. That is the competition. But if you look at the efforts put by both are, maybe the person who is winning had more practice, the person who had a more focus, the person who had a more strategy to apply at every step and what to do. Maybe that is the lacking in the person who did not win the prize. But it doesn't mean that the failures are really waste and the only winners are the ones who can deliver. It's not that. So same way, even in academics, even in personal career, to acquire 90%, whatever efforts you put, it's easier to achieve 90%. It is, but to achieve the next 10%, you have to put double the effort of what you put for gaining the 90%. So this is the thing we have to keep in mind and approach our problem, approach our life. I think we will lead to the success. I think I have taken more time than what is given to me. Thank you for that. Thank you for the opportunity. I thank the organizers for having me here to share my few ideas. And really, I see future in the students. You will be the people. You will be, maybe we will be watching you landing on the moon surface in next 25 years. Wish you all the best. Thank you very much.
Thank you, sir, for your inspiring words. A reminder that space exploration begins with a single question, a single dream, and a shared vision for a better tomorrow. To honor those who made this journey possible, I would like to request our local lead, Mr. Kaushik Yola, to kindly felicitate the collaborators, partners who have helped bring this event to life. Can we have a huge round of applause for sir? We would like to extend our heartfelt gratitude to our industry partner, Comet Care's Innovation Hub, whose guidance, mentorship, and support have been played a pivotal role in nurturing the young innovators for this challenge. Although they are unable to join us here today, their contribution remains truly inevitable. We would now like to invite Ms. Chetna Sarang, CEO and co-founder, Dattamsh EdTech LLP, whose vision and tireless effort in integrating education with innovation has greatly empowered our students, to please kindly come forward and receive our heartfelt token of appreciation. request Dr. M.S. Patil, Principal, Gopte Institute of Technology, to please join us on stage. Your guidance and collaboration has ensured the technical and scientific mentorship reached our young innovators seamlessly. It's our pleasure to invite Dr. Prasida Srikumar, founding principal, along with her leadership team, whose foresight and commitment has been the very foundation of this event. Please kindly come on stage and receive our token of appreciation. We would request Dr. Prasida Srikumar to please stay on stage and felicitate Mr. Kaushik Yola, our local lead whose dedication, hard work and meticulous planning has brought this event to life. Sir, please come forward and accept our heartfelt gratitude. Thank you, ma'am and sir. As we draw the curtains of this remarkable evening of innovation and inspiration, let us take a moment to absorb the essence of what we have witnessed. Imagination turned into invention, ideas molded into impact, and the brilliance of young minds that dare to reimagine the future. Each participant, mentor, and partner here has been part of a shared vision. A vision where knowledge meets purpose and purpose meets possibility. It now gives me immense pride to invite the architect of this extraordinary event, a leader whose foresight and dedication has made the NASA SpaceApps Challenge Belgavi a beacon of creativity and collaboration. A firm believer that innovation thrives where courage meets curiosity. Please join me in welcoming Mr. Kaushik Yola, our esteemed local lead, to deliver the vote of thanks.
Good afternoon, everyone. What an incredible journey it has been of innovation, talent, and passion over the past few days. As the NASA SpaceApps Belagavi local lead, it is my sincere privilege to deliver the vote of thanks and express profound gratitude to everyone who made this spectacular event possible. First and foremost, I extend my deepest gratitude to our esteemed chief guest, Mr. Hanumant Rayappa. Thank you, sir, for taking out your valuable time and gracing our event. So your presence is not just an honor, it is a monumental source of inspiration for all the participants here as well as those who are joining us live. Your dedication to India's space program sets the benchmark for all our young participants. Thank you for taking your time from your busy schedule and motivate the next generation of space explorers. Now I would like to thank to the organizations and teams whose infrastructure and support made this possible. Our heartful gratitude goes to our gracious host, Indus Altum International School. Ma'am, your support and the entire leadership team's support has been very crucial for this event to come to a reality. I would also like to thank our Vice Principal, Ms. Anjali Negi, Upper Secondary Coordinator, Mr. Sunil, and the entire leadership team once again. For the seamless execution, we owe special thanks to Major Mayank, Director of Administration, Mr. Gautam, the Admin Manager, and his entire admin team. And finally, to the marketing team and admissions team, Mr. Ujwal and his entire team for supporting us with the outreach to the overall execution of this event. Next, I would like to recognize the dedicated support to our industry partner, Comet Cares. Thank you to Mr. Ramesh, Mr. Sachin, and Ms. Vidyashri for the valuable time and the effort that they have put in to bring us more participations across the North Karnataka. To the wonderful team from Datamsh EdTech, Ms. Chetna, Ms. Arya, Ms. Ritika, Ms. Rekha, you're the behind-the-scenes coordination and operational assistance were truly invaluable for the success of this event. I would like to recognize the efforts of the judges who conducted the whole online judging process and went through each and every process to finalize the overall winners and give us global nominations. Just a quick clarification, all the 7 teams who presented today have been nominated for the global judging process. And finally, to the true heroes of the NASA SpaceApps Challenge, each and every participant who came forward to participate in this online hackathon this year, kudos to you. Please keep working on your individual projects because this SpaceApps Challenge is not just the end, it is just the beginning to your projects going forward. Thank you so much, everyone.
Thank you, Mr. Kaushik, for your steadfast commitment, your visionary leadership, and your quiet yet powerful determination to transform an idea into an enduring legacy. As Paulo Coelho once wrote, when you want something, all the universe conspires in helping you to achieve it. Your passion has indeed conspired with the universe, inspiring a generation to dream beyond boundaries and innovate with purpose.
As we bring this remarkable evening to a close, I request everyone to please stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you for being part of the NASA SpaceApps Challenge 2025 at Indus Altum International School. May your curiosity never fade and your imagination always soar. Until next year, keep exploring, keep creating, and keep dreaming. Thank you.